Hello, thank you for joining our presentation. My name is Jan, and I'm a data scientist on the research and modeling team of National City Bank. Today, we will present you, as the Chief Product Officer, a customer propensity model for a new line of credit. So our agenda today is to explain what the task was for our team, how we pre-process the historical data, how we explore the historical data, the data modeling and the models of AI algorithms that we will be using, then the results, the deliverables to you and the organization, and finally answer some questions. First of all, our task was to create a customer propensity model. What does this mean? Well, we as a bank are looking to provide a line of credit against a household's used car. We have a historical data of 4,000 past loans that were granted and not granted. It's a mix of both. And we will be using this past historical data to make predictions on a list of 1,000 prospective clients. So this prospective customer list has 1,000 prospective clients. We have about the same amount of variables that we had in the historical data, with the exception of two. I will be speaking about that later. And we are tasked to identify the next 100 customers from that prospective customer list. We will also present to you some customer profiles for both historical and prospective customers. So in order to pre-process the data that we had of 4,000 historical credit application, and we had these applications and the results of the application, the data was missing some fields. So you can see here it was missing some fields in education, some fields in job, and here you can see them in gray on each column. So for example, communication was missing less than past outcome, whereas we had information such as the year of the car that was missing for some of the lines, and we had the job missing for fewer of them. And this visual, it also shows you the type of data. So we had character data, such as the car model. We had the numeric data in integer, such as the car year and the age of the person. And we computed this column called duration. It's the duration of the call. How long it took to call the people that were historically either granted or denied applications. Now, this data that we computed here was based on two fields that we will not have in the prospective data. So on the next slide, I will show you something that we did with that data, just to show you that if we were to have the data, this data would be pretty useful, because we were able to subtract the call end time from the call start time and obtain the duration of the call. And we plotted that against the age of the person. So you can see there's a relationship between the age of the person and whether the duration of the call was higher and lower, and also whether people were accepted or rejected. So when people were accepted, usually the duration of the call was longer. Now, this is from one of our models, is showing you which variables the model thought are the most important. So you can see, for example, the age or the recent balance of the credit for the person are more important than, say, whether there were previous attempts or the pets purchases. So let's jump into data modeling. We use three models: logistic regression, k-near neighbor, and random forest. In order to apply these models, we had to simulate the data on the data the model didn't see before. So we took all data and we split it between 80% training data and 20% test data. This simulation between train and test is really important, because overfitting is virtually guaranteed on trained data. So we want our models to not overfit the data and generalize well. In other words, models that perform well on new data. These three models, we will go in more detail on how we set them up. First model, the GLM, we have the curves of the, it's called ROC curve. So this curve is showing you the false alarm rate. So if the curve is the area under the curve is closer to 1, then it means that the false alarm rate is low. So in a perfect world, it would be 1 if we are predicting perfectly. So you can see that the trained data was doing a little bit better than the test data that the model didn't see, but they were both pretty close and pretty good. So this is a robust model. And this model, what we did, we used a backward fit functionality so that we reduced the variable from 88 to 25. So that provided us less variables and made the model more stable. The other two models, we have a model called K-near neighbors. We did different iterations to figure out how many of these neighbors that the model is plotting against. So the model is looking for similarities between neighbors and trying to use different neighbors to do this comparison in real time. So we realized that the model was doing different iteration. We did 15 tuning iteration and it realized that 13 neighbors is a good, it's a good number of neighbors. We could have done more iterations, and after at some point you see the increase are negligible and it would have went down because the more neighbors the model would get confused with it. The last model that we used called random forest, we noticed that the amount of trees or votes that the model is taking is because it's a weak learning model. So the amount of trees that we used 3 trees and then we used 500, but then we plotted this to see what would be an optimal number, and we realized that 270 trees is the optimal number that will give us the highest prediction probability rate. So let's jump into the results. We have the 3 different models, and for random forest we also showed you the 3 and 500 votes for comparison, and we have the prediction probabilities. Sorry, this is the accuracy of prediction. So you have a plan data that is the 3,200 observations. It was almost always doing better than the test data, but we noticed that the prediction that we're showing you here is, for example, the real data was showing in the train that 1,289 accepted and 1,900 did not accept. So how did the models compare? Well, GLM was predicting 1,000, KNN was predicting 600, and the random forest was predicting the closest. It was predicting everything, but this model was overfitting in training. So when we actually did the testing, they were all 3 pretty comparable, around 75 to 80% prediction rate. So you can see that the truly number of accepted on the test data was 300, but the first model was the closest and the third model found 200. So they're all 3 pretty good models. Now, we provided you with the results on unseen data for all these 3 models. So what we did, we ran the 3 models, we created a treatment plan, made predictions, and created the top 100 for each model. And we will provide you this information in CSV files. And the numbers between these 3 predictions are pretty much 50 to 60% the same. So about half of the data is the same across the 3 models, top 100. But these are the top 100. So these should be narrowing down on who would be most likely to accept the credit offer, to be accepted for the credit offer. Now, the profiles that we promised you is over the historical data, we looked at what for the accepted only, the card that was most used as a line of credit was a Ford. The person was number one, a manager, and the age was around 31 or 33, and the car was fairly new from 2019. If we look at the top 100, we take K&N model as an example. We got this top second highest job as retired, and this car that you see here, it's a Suburban 2500. The year is 2012. So we got quite a different profile on the prospective customers, but that is normal because the model has learned and it applied the learning to new data. So finally, we would like to thank you. And if you have any questions, we'll be happy to answer you. Have a great day.